We are going to talk today about factoring a difference of squares. So let's do a little bit of a recall of expand and simplify when we have two binomials. And if you notice, the special case of this is that the two binomials have exactly the same terms inside, except we have one term that's positive and one that's negative. So if we remember expanding and simplifying this, we would get something like this. Using our expand and simplify rules, we would come up with something like this. And you'll notice that at the end, we have two things, whether it's variables and numbers or a combination of that. But we have something that is squared, another thing that is squared, and then we have a minus sign. And we call this a difference of squares. So now what we're going to do is do the opposite and factor it. So we're going to start with a polynomial or a binomial really that has square things on each end. So you can see the x squared is something that has a perfect square, and 25 is also something that is a perfect square. So you can take the square root of those, and then it always has a minus sign in between. So these are called perfect squares, and you can see, these are called difference of squares, and you can see that both of these examples are a difference of squares. Now, knowing that what we did with the expand and simplify, that we end up with a difference of squares, we can automatically in our heads go, oh, this is one of those special cases. It's like something squared. So we're just going to do the square root of whatever that first term is. We're also going to do the square root of whatever that perfect square is. So in this case, it's 5 and 5. And then we're going to put a plus and minus in there. Because we know if we do that, then when we expand and simplify, those two middle terms equal 0. And we end up with just what that is right there. So again, if we do this with a little bit more complicated looking one, we would still immediately recognize that in this binomial we have two perfect squares. So 9 is a perfect square, a squared is a perfect square. So that first term is a perfect square, and 16 is a perfect square, and y squared is a perfect square. So that whole term is a perfect square, and we have a negative sign in the middle. So since we realize that it's a difference of squares, we can put our two brackets and then our square roots of each of the terms at the front there for that one, and then at the end of each bracket there for that one. And then we know we need a plus and a minus sign, and that's all there is to a difference of squares. Let's try a couple more complicated ones. Your turn to try a few now. Take a few minutes and try these, pause this, and then you can play to review the answers. And here are the answers. Take note that you are taking the perfect square root of each of the terms in each of the binomials, and you are putting them at the beginning. So for example, beginning of each bracket. So b times b gives me the b squared, and then you're putting the perfect square root of the second variable in the question here. So that would be 7 times 7 would give me the 49. And then we are going to put a plus and a minus, and that ends up, those end up canceling out the middle terms when you expand and simplify. And remember, you can always expand and simplify on another piece of paper or in your head to see if you end up with the original question when you expand and simplify. But this answer here is what we are looking for when we say factor. So again, y times y gives me the y squared. 6 times 6 gives me the 36. Positive and negative cancel out the two middle terms when we expand. So we end up with that negative 36 because we have a positive times a negative to get that negative 36. And you can take a look through the rest of those and double check your answers and make sure that you pay attention to the positive and negatives. Notice it doesn't matter if I put positive first and then a negative, or a negative first and then a positive, as long as each bracket has the same terms overall, and there's one of the brackets, one of the binomials that has a positive and one that has a negative. It doesn't really matter which one comes first, the positive or negative. Here, we're just going to take this one step further and say factor completely. So I'm going to give you a minute to pause this and try this. My hint here is to look for a common factor first if you can. If you can't, then factor and then look within the bracket and see if there is any more work that you can do to even factor it a little more. So take a second now, pause it, and then turn it back on to see if you got the answers right. For this first one, you can see that we have a common factor of 2 for the terms 18 minus 32x squared. So we take out the 2, and then in the bracket we have 9 minus 16x squared. Then we always want to look inside the bracket and see if there is anything more that we can do to factor. And since it's 2 terms, we want to double check, make sure there's no more common factors, which there isn't. And then we look to see if there's a difference of squares. So in this one, there is a difference of squares. Both the 9 and the 16 are perfect squares, as is the x squared. And we have a minus sign in between. So we know automatically there that it is a difference of squares. We're going to take the perfect square root of each of the terms, put it into the brackets, as you can see that I did there. So there is the perfect square root of 9 and the perfect square root of 16x squared. And then we do that also in that bracket, and then with the plus and a minus sign. So let's try the second one here. Many of you will have done this. You'll recognize that it is a difference of squares. So you could take these perfect square roots of each of the terms, and we get 4x squared minus 9 and 4x squared plus 9. And a lot of people will think you are done there, but you are not. Remember, you always want to look inside each bracket or at each factor that you have and see if you can factor it a little bit further. If there is a perfect, or if there is a common factor, you should be pulling that out first. There is no common factor in this, but if you look at the first binomial, you will notice that it is also a difference of squares. So what we want to do is we want to break that one into 2 more pieces as well. So this can be 2x plus 3 and 2x minus 3. And then this one, the second one here, the second bracket, is not a difference of squares because it is perfect square and a perfect square, but we don't have a difference. We have a plus sign instead. So simply all you're going to do is copy that one. So you get 4x squared plus the 9. And you are done with that. So you have those, you should have those 3 brackets, and you know you are all finished when everything is multiplied and there's no more common factors and no more factoring that you can do within each bracket. These are the basics of factoring difference of squares.